Hello students, we are studying the consensus algorithm. So in previous two sessions, we have studied two consensus algorithm, proof of work and proof of stake. Then we have to learn a few more algorithms, proof of work, burn and proof of elapsed time also. So in this session, we will try to understand this proof of burn algorithm. This algorithm is very simple algorithm. I can explain in 2 to 3 minutes how this algorithm works and what is the concept of this algorithm. So we know that what is consensus mechanism. This is the mechanism of agreement between the different nodes. The different nodes will agree on the block, and if the nodes agree on the block, then that block is added in the Bitcoin network. And for adding a block, some node has to propose the block, and who will propose the block, that depends on the type of consensus algorithm used. So in previous two sessions we have studied proof of work and proof of stake. We know that how the block is proposed in the proof of work algorithm. In proof of work algorithm, the miners will compete each other for proposing a block, and uh, uh, for proposing a block, will give a mathematical puzzle to the mathematical puzzle to the miners, and miners has to solve this mathematical puzzle. The miner who will solve this mathematical puzzle first, that miner will get the chance to propose a block in the proof of work mechanism that we have studied in the previous sessions also. Then we have studied proof of stake. What is the concept of proof of stake algorithm? In the proof of stake algorithm, first we have to see what are the disadvantages of proof of work. In proof of work, for solving the mathematical puzzle, the computer should be high performance computer, and for solving the proof of work puzzle, lots of power is also required, electricity is also required. So in proof of work, the network servers adjust the difficulty level of the mining puzzle. And in proof of work, we know that the hash value that we calculate should be less than the difficulty target that we have studied in the session, which was dedicated for proof of work consensus algorithm. Then next algorithm that we have studied, that was proof of stake. What is the concept of this proof of stake? The miner, in proof of work, we don't use the word miner. Instead of miners, there is validators. In proof of stake, validators propose a block, and the node who will hold the larger currency, larger stake in the network, that node gets a chance to propose a block. So condition for proof of stake is that the node must hold a large amount of currency in the network, and so the node who is holding larger amount of currency, that node will get a chance to propose a block in the network. But the problem is that the node who is holding the larger currency, that node will get chance again and again to propose a block in the proof of stake. So for that purpose, to avoid such kind of monopoly problem in proof of stake, two algorithms are used: randomized selection and coinage selection. In randomized selection, we know that the lowest hash value and the amount of currency the node is holding, from combination of this, the node is decided. Node is selected. The node who will propose the block, that validator node is selected, depending on the hash value, lowest hash value, and larger amount of currency that node is holding. Then in coinage, but in this randomized selection, the other nodes can easily predict who will be the next validator, that can be predicted, because every node that who is holding the larger amount of currency in the Bitcoin. Then the next we have studied coinage selection. In coinage selection, from how many days that node is holding the coin, and number of coins that node is holding, that are multiplied, and coinage value is calculated, and depending on the coinage value the node is selected for proposing a block. So the condition for proof of stake is that the node must have the stake means node must hold a large amount of currency in the network, and the nodes who is holding the larger amount of stake, that node will get the chance to propose a block. So this algorithm so we have studied. Then next algorithm that we have to study is proof of burn. So we will see in this session what is this proof of burn. So students, this is the proof of burn, which is alternate consensus algorithm. This is the alternate algorithm to proof of work and proof of stake. Proof of burn is one of the several consensus mechanism algorithms implemented by a blockchain network to ensure that all participating nodes come to an agreement about the true and valid state of the blockchain network. So this is the purpose of this consensus algorithm. All the nodes should agree on the state of the system. All the nodes will agree on the block to be proposed in the network, and for that purpose this consensus mechanism is used. The proof of burn is one of the several consensus mechanism algorithms. So the blockchain consensus algorithm are responsible for keeping the network secure and for verifying and validating the transactions. So these consensus algorithms are responsible for keeping the network secure and also for verifying and validating the transaction. So proof of burn is often called a proof of work with proof of work system without energy waste. So this proof of burn is also called a system without energy waste, and it operates on the principle of allowing miners to burn virtual currency tokens. The basic concept in proof of burn we have to understand. There only in 2 lines I can explain this algorithm. In proof of work algorithm, the node who wants to propose a block in the network, the node has to burn a certain amount of currency in the network. The burn currency, once the currency is burned, the node will not get that burn. The node has to sacrifice this currency to show the interest. In that, the node wants to propose a block, and for proposing a block, for demonstrating the node that the node wants to propose a block, miners has to burn the currency. Once this currency is burned, once the currency is lost, that currency is not recoverable. The node will not get that currency. So it operates on the principle of allowing the miners to burn the virtual currency tokens, and they are often then granted the right. And once the certain amount of currency is burned by the node, that node will get the right to propose a block. The node will get a right to propose a block in the Bitcoin network. So these nodes are then granted the right to write the blocks in proportion to the coins burn. As we know that in proof of stake, the node who is holding larger amount of currency, that node will get the chance to propose a block. Here is the same thing. The node who will sacrifice a large amount of currency, the node who will burn the currency, who will burn the maximum currency, that node will get the chance the node will get chance to propose a block in the Bitcoin network. So this is the concept, a simple concept. So in previous sessions we have studied proof of work. We will take a revision of proof of work. Proof of work blockchain, such as this is one of the consensus algorithm, where in this proof of work miners compete to find a valid solution for a complex mathematical puzzle or cryptographic problem. The first miner, the miner who will solve this mathematical puzzle first, that miner will get the chance to propose a block in the proof of work mechanism. And the distributed network of nodes and other nodes then verify whether the proof is valid or not, and if valid, then miner gets right to permanently add this block into the blockchain, and miner will get the reward. Now miner gets the reward for adding the new block in the Bitcoin network that we have studied in the previous sessions. Then proof of stake also we have studied. We will take a short revision. So instead of using the hash functions as the in proof of stake algorithm, in proof of work, we know that the miners has to find a hash value that should be less than the difficulty target, and for finding the hash value, it has to solve the mathematical puzzle. So instead of using the hash functions, the proof of stake algorithm makes use of digital signatures that prove the ownership of coins, and the validation of new blocks is done by so-called validation is done by the forgers or validators, which are chosen in a deterministic way. Two algorithms are used. We know that randomized selection and coinage selection. The more coins a forger or validator is holding at stake, the higher the chance that the node is being selected as a validator, as a block validator or a block proposer in the network. So unlike proof of work system, however, the majority of proof of stake systems do not provide the block rewards. So instead of providing the rewards, the fee is given. The miners will get a fee for validating a block, a transaction fee in the proof of stake algorithm. So we know the basic concept of proof of stake. In proof of stake, the node must hold a certain amount of currency to propose a block in the Bitcoin network. Then in this session we have to study this proof of Bun consensus algorithm. So students, the proof of Bun looks like a proof of work algorithm, but with reduced rates of energy consumption. This algorithm requires very low energy consumption. So the block validation process of proof of Bun is based in the block validation process of proof of Bun based networks does not require the use of powerful computational resources. This proof of Bun algorithm does not require a powerful high performance computers as we require in the proof of work algorithm. Instead, cryptocurrencies are intentionally burned. You try to read this sentence. This is the only one sentence. This is the summary of this proof of work. Instead, cryptocurrencies are intentionally burned. Cryptocurrencies are intentionally burned as a way to invest the resources in the blockchain. So the candidates miners are not required to invest physical resources. So in this proof of work, proof of Bun, the miners don't have to invest their physical resources. Miners don't require high performance computer. Instead, miners has to burn certain amount of currency, certain amount of coins. Once that coins are burned, that coins are not available in the network. Try to understand this concept. And the amount of coin the node will burn, larger the coins are burned by the node, and the chances there are more chances that the node will get selected uh, to propose a block in the this proof of burn mechanism. So in other words, by performing coin burns, users are able to demonstrate, the users will demonstrate their commitment to the network by burning the coins, burning the coins. Users are able to demonstrate their commitment to the network and gaining the right to mine and validate the transactions. So by performing the coin burns, users will demonstrate their interest to propose a block in the network. So for that purpose, users has to burn a certain amount of coins. So since the process of burning coins represent virtual mining power, the more the coins a user burns in favor of the system, more the coins you read this sentence. This sentence is very important. Mm, you can read. I am highlighting the more the you can see. You try to read more coins a user burns in favor of the system, the more mining power he has, more the coins the user the node will burn, more mining power that the node will get. The higher the chance that the node will be selected as the block validator. The node will be selected for proposing a block. So higher the chance, the higher the blocks, the more number of coins, more the coins the user will burn, higher the chance that the node will get selected as the next block validator in this proof of burn. So in this proof of burn mechanism, how many number of coins are burned by the node, depending on that the node will be selected for proposing a block. Higher the coins that the node will burn, more is the chance that the node will be selected as the validator for proposing a block in the proof of burn. So how this proof of burn algorithm work? You can read these sentences carefully. In a few words, the process of burning coins consists of sending. These coins. The node will send these coins to public verifiable addresses where they become inaccessible and useless. The node will send these coins to public verifiable addresses, and after sending these coins to public verifiable addresses, that coins will become inaccessible and useless. And typically these addresses, eater addresses means the addresses that will eat these coins, that will consume these coins. Eater addresses, these addresses are randomly generated without having any private key associated with them, and naturally the process of burning coins reduces the market availability and creates an economic scarcity. Once the coins are burned, that coins are not available in the market, in the network, and it will create the shortage of coins and creates an economic scarcity, causing a potential increase in its value. Once, because coins will get reduced in the network, so value of coins will increase in the network. But more than that, coin burning is another way of investing in the security of the network. So one of the reasons proof of work blockchains are secure is the fact that miners need to invest lots of resources in order to finally be profitable. So you try to understand this consensus of consensus mechanism. In every consensus mechanism, miners has to invest either hardware resources, either their money. So we know that in proof of work, miners requires hardware, powerful hardware. Miners has to spend a lot of electricity. In proof of stake, miners has to hold lots of currency for proposing a block. In proof of work, proof of burn, miner has to burn the coins. Miners has to lose their coins, because after burning the coins, the miner will not get the coins back. Uh, these mechanisms are based on the concept that the miners need to invest. Miner needs to invest lots of resources in order to finally be profitable. This means that a proof of work miner will have all the incentives to act honestly. So in this mechanism, the miners will get the incentive for acting honestly in the network, and if the miner will not act honestly, miner will lose their currency, miner will lose their stake, their investment in the network. So on this concept, these consensus algorithms are based on. These miners will have all the incentives to act honestly and help the network in order to prevent the initial investment. So miners has to do the initial investment, and if miners will not behave properly, they will try to attack on the network. Then their investment may get wasted in this Bitcoin network. So the idea is similar to the idea is similar for this proof of work algorithm also. But instead of investing electricity, labor work, computational power, or either instead of holding the currency, proof of work blockchains are supposed to be secured by investment made through the coin burns. For this network is made secure by burning the coins and nothing else. And for the node to become a validator, to become a miner, the node has to burn a certain amount of coins in the network. And after, similar to the proof of work blockchain, proof of burn system will provide block rewards to the miners, and within a certain period of time the rewards are expected to cover the initial investment. So whatever the coins are burned, it is expected that the miner will cover this the investment of burn coins through the rewards. So this is the proof of burn. So proof of burn versus proof of stake. One thing that proof of burn and proof of stake have in common is the fact that block validators have to investment their coins in order to participate in the consensus mechanism. So in these mechanisms, in proof of stake, we know that the node has to hold certain amount of currency. In proof of burn, node has to burn certain amount of coins. Node has and once the coins are burned, the node will not get back that coins. So in order to participate in the consensus mechanism, the validators has to invest their coins to participate in the consensus mechanism. However, the proof of stake blockchains require forgers to stake their coins. In proof of stake, the forger, or we can say the validator, must hold certain amount of currency. They must have certain stake in the network. But if they decide to leave the network, in proof of stake, if the nodes validator wants to leave the network, they may take those coins back and sell them in the market. In proof of stake, if the forger wants to leave the network, then the nodes will get their coins back after a certain amount of time. So therefore there is no permanent market scarcity. The coins will not be lost in the proof of stake. But in proof of burn, if the node wants to leave the network, and if certain amount of coins are burned by the node, then it is not possible that the node will get that coins back. So therefore, on the other hand, proof of burn block validators have to destroy their coins. In proof of burn, the node has to burn the coin. That means node has to destroy the coins, and once that coins are destroyed, that coins will not be accessible. That coins are not accessible. That coins will become useless, and that coins are not available in the network also. Coins will get reduced in the network, and that will increase the value of the network. And if the node want to leave this consensus mechanism, then node whatever the coins are destroyed by node the node will not get that coins back. It is not possible to get the coins back. So this is the loss is permanent in the proof of burn, once if the node wants to leave the network. So on the other hand, if proof of block validators have to destroy their coins forever. The block validators will have to destroy their coins forever, creating a permanent economic scarcity. Once the coins are destroyed, once the coins are burned, that coins are not available. Coins will become useless. Coins are not accessible, and that will create a permanent economic scarcity that will reduce the number of coins in circulation. So what are the advantages of this proof of burn? This is more sustainable. It has reduced power consumption. There is no need for mining hardware. Coin burns are virtual mining rigs, and coin burns reduce the circulating supply. Coins burns will reduce the circulating supply, and it will increase the demand of the coins, and it increases the long-term commitment by the miners. If miner wants to leave the network, the miners whatever the coins are destroyed, that coin will not get back. It engages the miners for long time in the network, and coin distribution or mining tends to be less centralized. So these are the various advantages of this proof of burn algorithm. Disadvantages that some people say that proof of burn is not really eco-friendly because the bitcoins being burned are not generated through proof of work mining. Once the coins are burned, that coins are not generated through proof of work mining, which requires lots of require resources. For resourcing, generating the coins, lots of resources are required, and this proof of work is reverse of that. This proof of burn destroys the coin. It burns the coin, means it destroys the coins permanently, and that coins are not available in circulation. This is not proven on larger scales. More testing is needed to confirm its efficiency and security of this proof of burn algorithm, and the process of burning coin is not always transparent or easily verifiable by the average user. This is all about this proof of burn consensus algorithm. So students, in this session we have studied proof of burn algorithm. This is very simple algorithm. In this algorithm, only the concept is that the node who wants to propose a block, the validator, or you can say miner, has to burn the coins. Burn the coins means it has to destroy the coins, and once the coins are burned, that coins are not available. And the larger the coins the node will burn, more is the chance that the node will get selected for proposing a block in the network. So depending on the capacity, how many coins the node can burn, depending on that, there is a chance that the node will get selected for proposing a block in the network. And if the node gets selected for proposing a block, then we know that node gets the transaction fee, or we can say node gets the reward for proposing a block in the network. So in this proof of burn, the miner has to stay in the network for a long time, because miner destroys the coins, and to recover their investment, a miner has to stay for a long time in the network. So this is all about this proof of burn algorithm. So today we will, in this session we will stop here. In next session we will study last consensus algorithm, that is proof of elapsed time. So thanks for watching session. Goodbye.